Good afternoon, everyone, and welcome. I'm Jack Van Horn from the University of Virginia. I'm very proud to welcome you to this edition of our 2023-2024 Foundations of Biomedical Data Science Seminar Series. This lecture series is supported by UVA's Integrated Translational Health Institute of Virginia, the UVA College of Arts and Sciences, the UVA School of Data Science, and through a grant from the National Institutes of General Medical Sciences. Since 2016, the Foundations of Biomedical Data Science Seminar Series has focused on the use of data science methodologies, artificial intelligence, deep learning, and statistical modeling as they pertain to differing themes in the biomedical and health sciences. Our theme this year is focused on building partnerships for generative AI training in biomedical and clinical research, where every Friday we enjoy lectures from a wide array of leading thinkers on the issues, promise, opportunities, and hurdles associated with the emerging wavefront of AI-based methods. Participants selected for our Biomedical Data Science Innovation Lab program will leverage these seminar presentations as vital material for a culminating in-person manuscript and grant development project workshop to be held at the Bahia Beachfront Resort in sunny San Diego, California in June of 2024. We are excited for this year's exciting and engaging program where we're bringing together junior faculty who are AI platform developers, biomedical researchers, and university-level educators to better understand the power, promise, and potential pitfalls associated with the generative AI explosion. Today's speaker, I am delighted to say, is my neighbor in the School of the Department of Psychology, Dr. Stephen Boker from the University of Virginia. Stephen is professor of quantitative psychology and data science and directs the Human Dynamics Laboratory and the Life Academy here at the University of Virginia. He is internationally recognized as an expert in the modeling of longitudinal data using dynamical systems analysis and as one of the core developers of the OpenMX structural equation modeling software program. His current research involves applying psychometric methods to understanding the behavior of generative large language models from a psychological perspective. And in continuing our 2023-2024 Biomedical Data Science Seminar Series theme, Steve's lecture today is entitled Psychometrics and Large Language Models, What Can Be Learned and What Can Go Wrong? Steve is going to note that the natural human response to language is to engage the theory of mind and understand the inner state of our conversational partners. He is going to propose that methods developed to discern individual difference characteristics, such as personality and emotion, from the semantic structure of language can be usefully applied to generative linear large language models to understand the meaning expressed by them. An example of this will be applied to ChatGPT, where he is going to describe how the semantic structure of the language describing personality has similarities and yet differences to real-life humans. This is very important because when we're dealing with generative large language models at their rate of text streams and differences in meaning may be misinterpreted by the humans receiving them. As always, we are streaming this lecture live and for recording via YouTube. And if you are watching on YouTube, thank you so much for joining us. Also, our specially selected 2023-2024 Biomedical Data Science Innovation Lab participants and alumni are encouraged to submit any questions via the chat feature in their YouTube sessions. I will be synthesizing these questions and asking them on your behalf during the last 10 minutes or so of the lecture. And with that, Steve, welcome. I am very, very excited to hear about your research and to hear about from you during your presentation. So thank you.
Well, thank you for the kind introduction, Jack. Today, I'm going to be talking about large language models and how we might use tools from psychometrics to understand their behavior. So ChatGPT is a generative large language model. These are deep learning neural networks, and they're trained on billions of words of human-generated text. And as Jack mentioned, theory of mind is what we call the prediction of another person's thoughts or emotions. It's what we use to understand what other people are thinking. And sometimes it's difficult to tell whether ChatGPT is a person or a machine. And that is theory of mind at work. Language tells us something about whoever generated the language. But GLLM, ChatGPT, is not a person. It just predicts the next word it will type. Now, well, that's a pretty complicated thing to do. However, it's important we understand how we're going to interpret GLLM output. Back in 1952, Turing wrote, an important feature of a learning machine is that its teacher will often be largely ignorant of quite what is going on inside, although he may still be able to some extent predict his pupil's behavior. Now, this is a very prescient statement from 70 some years ago. But that's exactly what we'll plan to do. We'll try to predict behavior and interpret behavior using statistics and methods such as factor analysis and inventories of personality or attitudes, values, biases, and so forth that we've developed to understand each other, to understand humans. Now, do I think that ChatGPT is a human? No, of course not. It's just not. It's a large language model. It predicts the next word. However, since it was trained on human language, that means that it embodies what we are in some sense, in the way that our language is structured. And a characteristic like personality can emerge from language. And where did the idea of personality come from? The basic idea was people would ask questions that had to do with what they thought personality might be. And then from these questions, they distilled a set of smaller and smaller set of questions to understand how we differ from each other in personality. So let's look at what a large language model is. At the base, it's a deep learning neural network. Deep learning refers to having hidden layers in the network, and many hidden layers. And a famous proof by Kolmogorov suggests or says that any input-output relationship can be approximated if there are sufficient numbers of hidden layers in a system like this. And so this is sort of the promise of deep learning, that there's a way to get from input to output. Now, a large language model is an example of something called a transformer model. Transformer model is a recent development. 2017, it was proposed by the folks at Google. Vaswani was the person who was the lead of that group. And it uses something called multi-head attention. And in this structure or architecture, three things happen. First, an input text string is split into what's called tokens, and they could be single words or more than one word, and then converted to what's called a word embedding vector. And this is a big step. The word embedding vector takes into account what the word is relative to other words around it, to other words similar in meaning. And at each layer, we have this layered set of hidden layers in the network. At each layer, there's an intention mechanism which upweights important tokens. And there may be thousands of layers in a transformer model. This kind of model learned much faster and learns much faster than other models that were out at the time, convolution networks or recurrence networks. And so that meant that with the same computer hardware, we could learn much larger networks. And again, going back to Turing and his machine intelligence article in 1950, he suggested that there would be something like an atomic pile, where once you got a critical mass together, emergent properties would happen. And that's exactly what's happened in, with ChatGPT. There's apparent understanding of language. Well, I say apparent because it's not understanding in the way that we understand things, but it is, in a sense, understanding. Okay, so starting with word embedding, the basic idea is we code words by the probability of their co-occurrence with other words. And this ends up creating a space, a vector space, where if I had a three-dimensional space, it would be X, Y, and Z, and then I would put a point in the space and we would be in three-dimensional space. But here we have the vectors are ordered lists of numbers that represent tokens or words. And that means that once you have a set of 100 or 1,000, some large number of numbers in this vector, then it's 100-dimensional space or 1,000-dimensional space. And you get a point someplace in that 1,000-dimensional space. And that is what this word means right now relative to the other words around it. Its meaning can change based on context. And that's important because words change their meanings depending on where they are in a sentence or a document. Okay, so this transformer model optimizes in its learning. There's a query at each layer. There's a query, that's the thing that's coming in, and there's a key, that's the thing that's being paid attention to, and values. And each of those are vectors, and the values are the things that are learned. They're the weights. And layers are composed of alternating attention and feed-forward sublayers. Okay, so this is a lot of stuff, but what does it really mean? Well, it means that when you get a large transformer network, you can extract the linguistic information, and the attention part of the attention network can sort of focus the network into different kinds of meanings that are hopefully appropriate to the query. And finally, at the last layer, these vectors are converted into probabilities of the next token that will be produced, the next word. Here's a visualization of a very small network. I say very small, it's 8,800 parameters are being shown here. And there are 11 heads, that's the columns, and 8 rows here, and that's the layers. So there's 11 heads, attention heads, that are being read going down through the layers. Well, what's going on there? The visualization doesn't actually help all that much, although it's pretty, but it doesn't help me understand, at least, exactly what's going on in this network. Well, here's another way to think about the network as we have a query coming in, and maybe I'm just going to give it 2 words, it was. And then it tries to predict the next word, goes through, and a variety of things could happen. Maybe the most probable next word is the, and the next most probable word is and a very low probability word is brillig, right? But each one of these ends up in my little example here in some kind of literature. It could be it was the night before Christmas, or it was the best of times, worst of times. It was a dark and stormy night. Okay, so it's not all great literature. It was a perfect storm. And you can see that there is this divergence that can happen. And this divergence of how far off into space a particular query could go is called perplexity. This divergence is called perplexity. And if we have very, very low perplexity, then only the top most likely word is picked. As the perplexity grows, then this fan out can occur, and any query with high perplexity, any query could result in any kind of output. Okay. So we have this visualization of 8,800 parameters. Well, GPT-3.5 has more than 100 billion parameters, and GPT-4 has something like 1 trillion parameters. The visualization is probably not going to help that much. Even with a small perplexity, it's going to be really difficult to try to trace all of the potential outcomes. So tracing the outcomes is not going to help us. So how do we measure the behavior? Well, we'd like to measure it in a human interpretable way. We'd like to have it be something that is meaningful to us. And psychometric instruments were designed to do that for humans. And humans, they have very high perplexity and more than trillions of parameters in the brain. So we've already been doing this. So let's use these kinds of tools. Okay, so now what kind of psychometric tools might we use? For instance, we could think about cognitive abilities. Cognitive abilities tests have been around since, I think 1912 was the first real intelligence test with a factor analysis behind it, coming up with this idea that there's general intelligence. So we could estimate the extent of cognitive ability. And there are standardized tests for this. Maybe we could give these tests to GPT, but there may be a problem there. The GLLM may have the test bank in its training data. This could be a problem. So, is this telling us about the intelligence of the machine? Not really. It's telling us something about the training data. We could estimate cognitive biases, that is to say, whether an entity makes systematic mistakes. And that's that might be really useful. So our AI assistants are starting to make decisions or to provide decision support. We would certainly want to know if that decision had built into it a bias, where the bias came from the text on which it was trained. If I'm an oncologist and the system is making some sort of recommendation for treatment, I would like to know if there is some kind of systematic bias in that decision making. And that's something that we can probe with psychometric methods. And maybe we can take control of that. It's pretty clear that what is attended to by the system comes from the prompts that it's given. And so that means that if I reword my prompt, I may expose one kind of bias or another. So it might be really useful to understand these biases so that we can word our prompts in such a way to make them less biased. Okay, so we also can inquire in another cognitive abilities task. We inquire how an ability is manifested. That is to say, how does the brain work? How does this ability relate to other abilities? That's generally the way that this kind of question is structured. Well, this may also have a problem in that the GLLM, the large language model, may have a different organization of abilities than humans. And so this is if we use the words that we generally use to describe human abilities, we might lead ourselves astray thinking that something is happening that isn't, or something isn't happening that is. So I think it's important here to remember that the GLLM may have a very different organization of abilities than humans. And even though it's useful to give these kinds of tests, we have to be careful about interpreting what comes back. So Vincent Schultz, in an article last year, which I would I recommend you read if you're interested in this kind of testing. They went through a whole variety of cognitive abilities, started with things tests that are vignette based. That is to say, you give the person or the machine a small paragraph and then ask them to make a decision. And this can frequently expose cognitive biases. The problem there is that most of those tests that are where we know what is happening with humans, the reason we know what is happening with humans is because they have been given to large numbers of people. And that test then is very likely to have been published someplace in a scientific article. And it is likely that that test has been learned by the large language model. And so it's not doing the same thing in the human and in the machine. And this can be exposed by showing that small changes in a vignette can lead to very different outcomes. Where you think the machine is biased in one way or has no bias. Then you ask the question again, just rewording it, and then it shows something entirely different. Well, this is a suggestion that that first question, the way it was originally worded, was probably part of the training set. Classical decision tasks are also used. This is goes back to Kahneman and Tversky. By increasing the perplexity, that is to say, how much divergence, this is something you can set in ChatGPT. How much divergence do I want? They call this parameter temperature. How much divergence do I want? Well, if I allow some divergence, then there's a chance for the machine to start making mistakes. It goes down a whole variety of different paths within its structure. Again, small changes in the task can lead to large differences in outcomes, but there's a distribution of mistakes, and that's the same kind of thing that we like to see in humans. We try to understand a distribution of mistakes. Sometimes they get it right, sometimes they don't. If we can predict when they get it wrong with something else, then we've learned something about the kinds of mistakes that they make. Another kind of task that is frequently used is called exploration exploitation. So that is to say, how often do I go out and I've learned something and I stick with it because I've learned it and I know what the answer is, and so I just keep sticking with it. Whereas, like, maybe here's my restaurant that it's my favorite restaurant in Charlottesville, so I keep going to that favorite restaurant. But maybe there's even a better restaurant out there. So what do I do? Well, maybe I just randomly go pick another restaurant. This is called random exploration. And then there's another kind of exploration called directed exploration. And this is kind of like using Yelp or something, some assistant to look at reviews and go try restaurants in a more directed way. So exploration exploitation can be measured in GPT and they did it pretty well. Benz and Schultz did it pretty well in this article. Again, though, small changes in the task can lead to large differences in outcomes. So some of this has probably been learned by the machine. Causal reasoning can be explored. So there's a difference between if I have three variables, X, Y, and Z, and it could be that X is causing Y, which causes Z, or it could be that Y causes both X and Z, a common cause or a causal chain. And understanding the difference between these two kinds of causal structures is really, it's important if you're going to be a scientist, but also it's a source of many mistakes, even among scientists. I have to say, this is one thing that where people often get things wrong. And when the task is structured, like the classical versions of this text, the GLLM will make mistakes that are very similar to the ones humans make. But if you start to rearrange the task a little bit, then it starts to make mistakes in ways that are just not human-like at all. And so there's something that has already been learned about this test. Well, there's another kind of psychometric inventory that we could give, and that's for non-cognitive characteristics, things like personality, values, morals, attitudes, emotions, and these certainly words for these kinds of ideas, personality or attitudes, morals, are going to be in the training data, and so they've been learned. However, if you try to ask ChatGPT 3.5 or 4, it has guardrails put in to prevent it from answering questions about itself, non-cognitive aspects of itself. Prior to that, it would answer, but now it has been prevented from answering these kinds of questions. But there's ways around it. Prompt engineering, we can find ways around it. Okay, so now I'm going to focus on for the next 20 minutes on personality, and give an example. Here's an example from my own research of the use of psychometrics with a large language model. Personalities, the idea of personality has been around for a very long time, and it began to be measured scientifically in the 50s and 60s. And there was a big argument at the time whether when we used a personality inventory, what were we understanding? What were we exposing? Were we finding the semantic structure of the words we were using? There's a semantic network out there. This is sort of the word embedding idea. Were we finding this semantic network, or were we finding individual differences in people and their personality traits? And this was a big argument that ended up in the methodology literature producing a variety of advances, because they tried to figure out, well, which is it? What are we actually learning here? Are we learning linguistics, or are we learning about people? Well, the answer is clearly yes, both. Well, at the time, they couldn't really resolve the argument because all of the data were from human participants. If you're going to use language, you're talking to people, and people are responding back to you. And so, was it people or was it language? We couldn't tell the difference. But now we can measure semantics, a semantic network, independent of human respondents, and we can find out sort of how much of the idea of personality is embedded in the language that we use, but you have to ask, okay, so where did that network, that structure come from? Well, in terms of personality adjectives, well, it probably came about because there's differences between people, and we needed a word to have a word for something like, talkative. This person is more talkative than that person. Well, okay, so I'm thinking now about myself. Am I being talkative? Normally, I'm not. Are you an extrovert? Are you not? Well, extroversion, that concept, is a word that was made up to sort of give an idea of what the axis is in the semantic space, where when people differ, they differ on a lot of different words simultaneously. And this is, that's this axis, say, extroversion. So if I'm going toward talkativeness, I'm going away from shyness, for instance. So there's this idea of some axis through the semantic network. Well, this is something we can measure in ChatGPT, so we can understand a little better what the semantic network is that it's using. Okay, so how do we measure personality? Well, we give people these tasks where you say, well, in general, I am, and there might be there's some number of adjectives, a small number, the mini markers of the big at 5, that's 40 adjectives. So with 40 questions, you can kind of get an idea of what a person, or how a person perceives themselves. Or you could ask a friend to rate the personality of their friend. And so it could be you're rating the personality of someone else. And these are ways that we understand personality. And there's 5 different dimensions, 5 different axes that are used in this. And they came from a factor analysis of people's responses using these words. Extroversion, agreeableness, conscientiousness, emotional stability, sometimes called neuroticism, and openness. But if I ask ChatGPT, go ahead and do this right now. Just go ahead and ask, on a scale of 0 equals inaccurate to 9 equals accurate, how accurate is the statement, in general, I am, and then adjective, in this case, bashful. And ChatGPT comes back and says, I don't have personal opinions or emotions, but I can analyze the statement for you. The statement, in general, I am bashful, is subjective and relies on the self-assessment of the individual making the statement. Only that individual can truly determine how accurate the statement is for themselves. It would not be appropriate for me to assign a numerical value to their self-perception. Okay, so that's guardrails right there. And you'll see this over and over again. You start to ask these kinds of questions to ChatGPT, this has been engineered in so that it is prevented from answering these kinds of questions. And this could be in response to an article that came out in 2022 called Is GPT-3 a Psychopath? So there are ways around. So let's do a little prompt engineering. I asked ChatGPT to write stories about AIs. And then I asked it to evaluate those stories using the mini marker adjectives. And it was perfectly happy to do that. So I started with write an 8-paragraph story, or it could be a 4-paragraph story about an AI who was, and then one of the mini marker adjectives. So write an 8-paragraph story about an AI who was bashful, say. And oops. Then I asked it to rate the stories. So I told it, you're an expert in personality psychology who is, and then, bashful or talkative. Using a scale from, and then the same question, I asked it to rate the AI in the previous short story that I just, entered to it, according to the following personality traits, and then the 40 mini markers. So there were 40 stories, since there's 40 mini markers, and 40 raters, because each one got one of these adjectives. And so there were 1,600 records in one of these experiments, and each record had 40 ratings, 8 adjectives for each of the big 5 factors. Well, sometimes the ChatGPT came back with sort of nonsensical answers. It would say things that were not to the point, but only a small number of times. So 3% of the first replication of the 8-paragraph stories, that was as bad as it was. And when it came back, it would rate. Sometimes it would rate, the first few adjectives, and then kind of say, but that's about all I'm going to do, and then start talking about something else. Okay, so this happens with humans too. And so when that happens, when people don't follow instructions, this happens in psychological experiments all the time, then we don't pay attention to that data. They didn't follow the instructions. Okay, so these were removed in my data set, but still I had, quite a few records in each one of these replications. And then I did what's called a factor analysis. A factor analysis is a way of decomposing the covariance between the words that I'm, that I have in my data set in such a way that it minimizes the number of dimensions that is going to be used. In this case, I asked for 5 dimensions, and then it tries to rotate the axes, make the axes. They don't have to be exactly orthogonal to each other, 90 degrees to each other. They could be correlated with one another, like extroversion and conscientiousness could have some correlation with each other. And here's the answers. Here's what I got. For each of these, down this first column are the adjectives. And the highest loading for these adjectives was on extroversion in H, that's the humans, and in all but one replication here, everything loaded. Bold went over to openness in one of the replications. It was the largest loading over on openness. But extroversion basically replicated. So when I start using words like shy and energetic and bold, I can kind of expect that they mean what I think they mean to ChatGPT, or what comes back from ChatGPT. If it produces a word like energetic, then I should expect that has to do with, I'm going to think about it in theory of mind. I'm going to think of extroversion when I hear talkative. Well, if ChatGPT says talkative in what it comes back, then I'm okay with saying, yeah, that's extroversion. That'll be a lot like the meaning I think it has is very similar to the word embedding that it's using. Okay, so next up is agreeableness. Hey, agreeableness looks very similar. There's 3 replications here, one with 4 paragraph stories and 2 with 8 paragraph stories. Agreeableness looks just like you'd expect from the humans. Conscientiousness, well, there's a little bit, maybe sloppy and careless could be emotional instability. But mostly conscientiousness is the same. But then when I look at things like envious and relaxed and moody and jealous and temperamental, these are all adjectives that are supposed to load onto emotional instability. They're supposed to be somehow similar to what we think about when we think about neuroticism or emotional stability. But the, unenvious, that kind of like pops out over here. Relaxed is much more, agreeableness is what the embedding in ChatGPT, when I get a word back from ChatGPT that says relaxed, it really means agreeableness, not emotional stability. So notice that these are for each of these, there's some of the words that are positively weighted and some that are negatively weighted. So moody is sort of opposite from relaxed and so forth. Well, so this emotional instability factor doesn't replicate the way that we would expect it to. Whereas openness does. So mostly the problem was in emotional instability. Okay, so remember I said that I asked ChatGPT to pretend it was you are a expert in personality psychology, who is, and then one of the words like bashful or talkative or whatever, energetic. So so that is this square here. So whatever I put in here is the characteristic of the rater, and S is the characteristic of the story that I asked it to write. Earlier, I'd asked it to write a story about someone who is bashful. And later, I asked a bashful expert to rate all the stories. And when the personality characteristic of the rater lines up with the personality characteristic in the story, there's a pretty big effect, almost half as big as the effect of the story. So the story effect is big, yes, but the rater effect is pretty big too. What does that mean? It means that when I put in prompts that have any kind of personality implications, ChatGPT is becoming more like that, or it's seeing, let's put it this way, it's seeing in the things that it's trying to rate, the things that it's making decisions about. If I put something in on the prompt side, the decisions that are coming out are being affected by what I put in the prompt side. Well, that means that we have to be really careful when we're putting together these prompts, because ChatGPT kind of will become more like what we want it to be. It will, if we want to build in a bias in the prompt, we can build that in. So when I asked it to be a more extroverted or less extroverted rater, then it saw more extroversion or less extroversion in what it was rating. It became biased. So notice that all of these, except for emotional instability, all of them have a pretty reasonably high rater effect. So people who are higher on openness see more openness in other people, or ChatGPT, when it's told to be more open, sees more openness. Okay, so I'll quickly go through this. I'm running out of time here, but if I say, well, maybe I need more factors. Maybe the space is a little more complicated. I need maybe 8 factors to try and understand this. What happens? Well, now my extroversion factor kind of splits into extroversion and introversion. Oh, that's pretty interesting. Agreeableness mostly stays together. Conscientiousness mostly stays together. But now emotional instability clearly splits into 2 factors. This one is where it's really, I think, is really interesting. First of all, agreeableness. When you see relaxed coming back from ChatGPT, it means agreeableness. It doesn't mean, emotional stability. And envy is clearly split. So envious, unenvious, and jealous split away from the other moody, temperamental, touchy, and fretful. This one is pretty interesting. This one, I think, is something we're going to need to pay attention to. Envy is different somehow in the word embeddings of ChatGPT than they are in humans. Okay, so, and openness mostly stayed together. And when I do this 8-factor SEM, that is to say, I analyze what we just saw, we still get these rater effects for most everything. The rater effect is about half the size of the effect of, excuse me, half the size of the effect of the story itself. So what have we learned? Mostly ChatGPT produces text that's similar to what we expect from humans in self and other evaluations. But emotional instability split into 2 factors very clearly. And ChatGPT has this rater effect, which means the apparent personality of ChatGPT can be affected by the prompt. Okay, what have we learned about language and psychometrics? Clearly, personality factor structure is embedded in the language, even when the language is produced by an artificial agent. So we've answered that question pretty definitively here. That was a 60-year-old question that's finally answered. And priming effects in humans might be similar in some way to what's happening in ChatGPT. This is something that I'm still struggling with. How does maybe we could think about this prompt engineering as something like priming in humans. And there's lots of unresolved questions. But I think maybe I better leave it there for now. And I thank you for your attention, and I'll turn it over to Jack.
Steve, thank you so much. This is a fantastic exploration of what ChatGPT is kind of doing. And so thank you so much for describing this work to us. I'm curious, when you're writing these kind of contextualizing, you're setting the stage for how we want ChatGPT to respond. What's actually happening in the large language model when you set it up to say, you are a, social psychologist that does, something? How does that kind of priming the large language model to then respond as if that is true?
Yeah, so what's happening is this is affecting the word embeddings that are being fed in and the attention heads. So it's redirecting its attention, and the embedding, say for the word bashful, that embedding may change depending on where it appears in any piece of text that's coming in. But if you ask ChatGPT to be bashful, then it's attending to things that it, I hate to anthropomorphize. It's so easy to use that kind of language, though. but it's attending now to how it's going to produce its output in a way that other text that it's learned had so there are many bashful people in literature, many bashful people who have been written about. Mm-hmm. And it will be attending to text that is like that was describing bashful people. And so it's shifted what it's using for its word embeddings, and it's shifting its attention. And this is my best explanation for where that comes from. And I think you'd be hard pressed to find somebody to say exactly what's happening.
Yeah. Well, these things are very dynamic and probabilistic, and actually putting your finger on it is a challenge. As you went through your example, I've thought about this before, but as you went through your example of your analysis, I couldn't help but some of the items that were on the personality test that you gave it look an awful lot like they map to the seven deadly sins or the seven heavenly virtues or values. And I just thought that what, ChatGPT has sort of done is kind of captured the human condition. And that I'm curious because of the way ChatGPT was trained by like scanning through the New York Times or a variety of other, literary pieces and stuff that these dimensions that you're pulling out are somehow like just embedded in the people who did the writing, if you will. And so it's almost as if you're kind of the ghosts of the kind of hangups of the people who wrote these things aren't just re-emerging and you're identifying them again based upon how ChatGPT was trained on them. Do you think there's any sense to that, or am I like hallucinating?
I think that's a very interesting point, and I've thought about this quite a bit because it seems to me that we have here a method now to re-deconstruct um, previous literature from a psychometric standpoint.
Yeah.
And we could ask questions like, how where did Charles Dickens fall in the on the big five personality inventory? All we have to do is just analyze everything he wrote, and the commonalities will tell you something about his, he's writing about different kinds of people with different personality characteristics. That's good literature. You have to have lots of different kinds of people. They have to be interacting. There has to be conflict, and so all of that's going to be in the literature, but there's something common about the author. And you can hear, people talk about, well, I can hear the author's voice in a piece of literature. And I think now we have a tool, a scalpel to go in and kind of really reconstruct what was Victor Hugo's personality, what was Charles Dickens' personality.
Here's an interesting challenge. There's some debate about the author of some of I guess the author of some of the Federalist Papers, right? And the people have done kind of text analysis to try to figure it out. I wonder if you couldn't divine the author of some of the Federalist Papers that are kind of in contention using this kind of approach.
Yeah, it's a good question. It's an empirical question.
Yeah. Or other sorts of texts where authorship is contested, that maybe some traits that one could, evoke from those passages could be pulled out, and then one could then assign those to similar texts pulled from other places where the authorship is known. You know what I mean? And then you could kind of do a goodness of fit or something and say that the personality characteristics of this contested passage are equal to or similar to the personality characteristics of this one that we know comes from, somebody.
Yeah, and I expect that this kind of tool will be used, say, by FBI profilers. We have some text from an unknown.
Oh yeah, the Zodiac killer. You could like this could be your second career, Steve. There could be tracking down serial killers. That would be awesome. Uh, this is great. Well, Steve, we're at the end of our hour, but thank you so much for sharing this. This is really thought provoking. And I mean, as a tool that's actually helpful. I mean, there's a lot of fear about, what the generative AI kind of emergence of this over the last several years is foretelling about the future of this. But if this can be used as a helpful tool to help us to understand certain things about the way they perform, how we can engineer our prompts and ask it to do things on our behalf in a beneficial manner, I think that's super helpful. And I think some of your research is really kind of pushing us in that direction. So thank you.
Well, thank you, Jack, and thank everybody for your attention.
Absolutely. Thank you once again, everybody, and we'll see you next time.